Hello, everyone. I'm Sara Adams. I'm one of the founding engineers of EnchFlow. And before EnchFlow, I was actually a software engineer with Google for 11 years, working on privacy and security of the Google account. So I've been a Bazel/Blaze user for quite a while, but this is my first BazelCon, and I've only quite recently started contributing and helping out with Bazel myself and not just being one of the bystanders. So I'm having a blast here. What a fantastic event this BazelCon is. And what a fantastic first day we had, right? This has come together with like a lot of people organizing, but everyone here too, everyone within the community, like everyone giving great presentations, you just being here, like having insightful conversations, asking interesting questions. And let's not forget about all of the people joining remotely that are just as much part of this community. So I also wanted to comment on, what a tough job does the Bazel team have? Engineers are an excruciatingly difficult crowd to please. And in some ways, it feels to me like all of the topics that have been presented so far have been about pulling apart the tagline of Bazel: fast, correct, choose two. We wanted to be faster. We wanted to be more correct, if that's even a thing. And we want more, right? We want integrations, we want new features, and we want to extend that set of two and then pick all of them. So we've plastered all of these, like we want more things on top of it. But I wanted to reiterate, like, one thing that all of it has in common is that Bazel is great. And let's not forget, like, that when we point out things that could be better, it's just because we love Bazel and we as a community want to improve it even more. And I think that's like a wonderful thing. And as I'm an engineer too, of course, I also have to nitpick and say, I want things to be faster. So let me take a step back and tell you about how, first, I wanted to ask actually, how many of you have looked at a Bazel profile in the past? So that's quite a bunch, almost everyone actually. How many of you regularly look at a Bazel profile and use it to improve the performance of your builds? A lot fewer. I wonder why, but one of the things is that with the Bazel Invocation Analyzer, we want to make it a lot easier so that hopefully a lot more people more regularly actually use it. But now I want to take a step back and tell you a bit of how it all began. So in April, we met in Madeira, and this is me right there. And just behind me, there's Laszlo Chamor. He's also one of the founding engineers of EnchFlow. And you may know him because back in the day, he actually helped build Bazel. And he gave a workshop on Bazel profiles, kind of letting us understand how we can analyze them. And I was absolutely amazed by all of the great data that was in there and how even sometimes a visual inspection of the Bazel profile seen in Chrome tracing could point you in some directions of how you could improve your Bazel builds. But you do need to know what to look for. And that's not easy. That can be quite tough. So I wondered, what can we do to make this more accessible? What can we do to empower all Bazel users at any level, whether you're new to Bazel or you're really experienced? What can we do so that we can all leverage that power to make our Bazel builds faster? So we started the Bazel Invocation Analyzer. It takes the Bazel profile and it generates suggestions in a more human-readable form than just the Chrome tracing view to point you in the direction of what you might want to investigate. And yes, we have open sourced this, so you can download it, you can play with it, you can extend it and, just carry it forward. In terms of technicals, it's a Java library and a CLI attached to it. It uses protobufs so that it's easier to integrate into other environments. And it's hosted on GitHub, so you can check it out there. Now, to prove to ourselves that it's easy to integrate, we integrated it into the results UI for our customers, where you can then analyze the Bazel invocations that you ran with our remote execution service. But more importantly, we also did an integration into a public web UI that is accessible to everyone, so that even without having to download the source code and compile it, you can just upload your profile and get suggestions on what you might want to do to improve Bazel's performance for you. Now, what is a Bazel profile actually? And Bazel has a lot of documentation and it can be really valuable, so why not look there? In the command line reference, the holy grail of all documentation, it says that for any build-like commands and query, or if you set this flag, a JSON format profile is written to the output base, and it includes some profile information. And it also helpfully indicates that you can view that profile with Chrome tracing. And there's some issues with that. And one point I wanted to make is I'm always talking about Bazel Invocation Analyzer. And I wanted to clarify, I like to use the term invocation, because when we talk about Bazel builds, in some ways, sometimes we don't think it's also Bazel tests or Bazel coverage or whatnot. So now when you try to open a profile in Chrome tracing, it might not always work, because while it is just a text file, it can be multiple hundreds of megabytes large. And this is a bug report from our CTO, Ulf Adams, you might know him too. And he said, I tried to open this profile that's over 500 megs large, and Chrome tracing couldn't handle it. It just crashed. So there's some restriction as to how easily you can view the profile, depending on its size. But even then, as we discussed earlier, even if you can look at it in Chrome tracing, you might not be easily able to figure out what to do with that information. There is also the Bazel subcommand analyze profile. It takes the Bazel profile and then it outputs information about the phases Bazel ran through for that invocation, as well as timing information, and it outputs the critical path. That's valuable information. But as we've seen in Chrome tracing, there seems to be a lot more data in that profile, and so probably we can do a lot more than just that. So let's compare. I'm going to switch over to demo mode, and we're going to run a Bazel analyze profile. We're going to look at a profile in Chrome tracing, and then we're also going to look at what Bazel Invocation Analyzer has to say about that profile. So first, let's switch over to the console, and we'll just do Bazel analyze profile. And I chose a profile from Envoy. They're using our remote execution cluster. If you ever want to check out our URI or whatnot, it's publicly available. I chose a profile with some interesting properties just for demonstration purposes. And here you can see when you run this, you get the different phases printed out, and you have the critical path printed out. So that's that. Now, if we head over to Chrome tracing, we can load the profile, this one. And here you can see that profile. For those of you that haven't looked at these profiles before, in the very top, you can see a timeline. It indicates how long the invocation ran. as well as it gives context as to when all of these events that are listed here actually happened and how long they took. And then there are multiple threads here on the left. The first one here is the action count. It basically tells you how many actions were executed in parallel by Bazel. Then there is some information on CPU and memory usage. The critical path is listed here, which was also extracted by the subcommand we just saw. And the main thread, which essentially has the information that was output with regards to the phases that Bazel ran through. There is a garbage collector thread, which keeps track of how often garbage collection has to happen for Bazel itself. And then the meat, somewhat, of the Bazel profile are all of these Skyframe evaluator threads, which list which actions happened when, and you can zoom in and look at details about them and whatnot. So that's the profile in Chrome tracing. And does anyone see here something suspicious about the profile, what they would investigate to improve performance? You can shout out if you do. And if not, that's fine too. Let's see what the Bazel Invocation Analyzer has to say. So I'm going to upload the same profile here. And then we will see that the first suggestion here is to break down bottleneck actions. By the way, there's also a small overview here, and this indicates that the profile looks like remote caching and remote execution were used. And here it says break down bottleneck actions, and you will see there's a couple of sections here. There's a recommendation that gives some indication of, what we think you might want to investigate. A potential improvement, a rationale describing why we're making this suggestion, and maybe some caveats. And now, break down bottleneck actions, it says here, the profile includes a bottleneck lasting 4 minutes and 35 seconds with an overall action count, with an average action count of 1.67. So let's quickly switch back to this profile. This is the action count. So let's look at this. In the beginning, it's 0. That's not unexpected because during the analysis phase, we're not actually executing actions. And as soon as we hit the execution phase, which you can see here indicated in the main thread, it goes up and it stays nice and high. We like that. That's good parallelization. And then suddenly it drops down. And then for the longest time of that build, it stays really low. And that is a bottleneck, right? We are executing, if you zoom into this actually, you can see the value here is 1. It's exactly 1 action, and it coincidentally is also where the critical path is executed. So the suggestion we're making here is to look at these actions and see, can you break them apart so that you have more parallelization? And the potential improvement given here is quite high because, as we can see, there's a very long duration of that bottleneck compared to the whole duration of the invocation. And there's a bunch of other suggestions given here too, but I hope you get the idea. And I'm hoping that this is much easier to process than just looking at the Chrome tracing render of the profile. And I think now I'm going to switch over to the slides again. So how does it work, right? We've seen what it does, but where does this all come from? So in essence, the Bazel Invocation Analyzer is a collection of modules. And we try to set it up in such a way that it's very flexible so that we can extend it in the future. So we have some external inputs. In this case, we have one external input, which is the Bazel profile. And then we have data providers. And these data providers have the job of extracting facts from the Bazel profile. And then we have suggestion providers, which take all of these facts that are available and compile suggestions on top of that. So while the data provider should be objective, the suggestion provider can be very subjective. And those suggestion providers give us suggestions, which is what we're really interested in. Now, the architecture is not quite that simple. To give a bit more context, we do have a data manager. And in that, we have datums. Datums are facts that are extracted by data providers. And this data manager opens up the access to datums in other data providers. So for example, I could have one data provider that uses data that was extracted by another data provider. And of course, the suggestion providers can access any of those datums too. So in essence, we have some sort of dependency injection here. So this is quite high level. So I wanted to do a code example to show you how it all fits together, but at the same time show you how you can extend the tool yourself by just trying to add one new suggestion. So the first step when you want to add a new suggestion is actually to come up with some idea of what data you want to extract and what kind of suggestion you want to provide. This is the tough point. This is like where you need expertise, you need some knowledge. Maybe you looked at a couple of profiles and you recognized a pattern that was helpful. This is the core of what we want to put in the Bazel Invocation Analyzer so that every Bazel user can profit from that knowledge that you might have. So in this case, let's look at, where is that? Let's look at the garbage collector thread. It looks a bit suspicious because there's a lot of garbage collection, and it also looks quite lengthy. Here you can see in the detail view, it's actually 3.5 seconds all over the place, and it actually says it's major garbage collection, which indicates that Bazel will stop doing whatever it should be doing, and it needs to wait for garbage collection to stop. That sounds like something we could optimize. And it's also some data that looks easy enough to extract. So once we have our target, we now go on to first define a datum. We're going to call it garbage collection stats, and for now, let's just add one entry, which is the duration of all garbage collection that's marked as major. So easy enough. I'm obviously for this presentation like omitting a lot of code and simplifying it down, but if you want to look at the full source code related to this one suggestion, you can head over to GitHub and check it out. Now, the second part is once we've defined our datum, we need to extract it from the profile. So for this, we have a data provider, and there's two parts that we need to implement. The first one is get suppliers. And this is what basically tells the manager, the data manager, what kind of datums are being supplied by this data provider. We could provide multiple datums, especially if it's more efficient to extract them in parallel. And here we're only actually supplying one datum, the garbage collection stats. We have some built-in memoization. If you think that it's appropriate that this is memoized so that the calculations are only performed once, even if the datum is requested by multiple other data providers. And now we need to do the real work of actually, extracting that data. So first of all, we need to fetch the Bazel profile. This is a built-in datum that's already being provided. And then we look at the profile and we filter for the garbage collector thread because that's where we found the data we wanted to extract. Then we're going to get all of the events within that. And we're going to filter for anything that looks like major garbage collection to then extract the duration and add it up to get the total duration of all garbage collection that's marked as major. And we're going to stick it into that datum object that we defined before. So that's that. Now we've extracted some data. Those are facts. Now we go on to a suggestion provider, which has one job and it just has one method that needs to be implemented, and that's get suggestions. What do we do here? Again, we ask the data manager to get suggestions, to get the datum, and that's the one we defined, garbage collection stats. And then let's just check, is it 0 or not? And if it's not 0, we're going to return a suggestion, and else we can just return nothing. So a suggestion, as we saw in the UI, has a couple of components. It has a title, it has a recommendation, and then it has 3 optional sets of data. That's the potential improvement, that's the rationale, and that's the caveats. So we didn't really talk about what kind of suggestion we wanted to do. I kind of said okay, let's extract the garbage collection, but what do we actually want to suggest? And well, if there's garbage collection, what if we just increase the Java heap size? It's like putting a Band-Aid on it, but sometimes it might be enough. And it's a valid option. So here's the first suggestion we're going to do. It's increase the Java heap size available to Bazel. But that's quite high level. So let's make it more concrete and actually point out the Bazel flag that you can use to increase the Java heap size, and also point to the documentation that gives more context to it. It's always great to have well-documented tools, and pointing people to that is usually the best way. It also is good and up to date. And then we want to add some rationale. If you increase the Java heap size, then the frequency and the length of major garbage collection might be reduced. And as I said, it's really just putting a Band-Aid on it, and I'm sure there's better suggestions you could make, but this is a start, and at least it's very easy to execute. You just add one Bazel flag. On to the potential improvement. Now this has 2 parts. You can provide a message, which is free form, and the second one is you can actually put it in a number if you have a good indication of how much improvement, how much speed up you could potentially achieve. So in this case, we want to give some context. So let's just fetch another datum that's already been implemented, and that's the total duration of the invocation. And then in the potential improvement, include how long the invocation took, how long it might take after, and also some assumptions you might be making. Well, this assumes that all of the garbage collection can be eliminated so that there is no stop the world pauses of Bazel anymore. And then in this case, we can easily add it in a number, because we can just remove all of the time used for garbage collection and then say, this is the best you can achieve. So overall, what we've done is we fetched 2 datums. One we implemented ourselves, and one was already there that we could just get. And then we checked whether we wanted to return a suggestion, and did if we wanted to. So that's basically the gist of how it works, right? Find a pattern, get the data, and then generate suggestions. So let's see what we actually have when we run this on the profile that we looked at. I'm going to analyze a new profile, and now use the one with major garbage collection. And here you can see the first suggestion is a different one, but the second one says increase the Java heap size available to Bazel, and includes all of the data that we saw before. There's a section suggestion here actually, which is related to the same data we looked at, which is investigating whether the memory use of some rules can be improved. Most often when you see a lot of garbage collection, it points to suboptimally implemented rules. And here we're pointing to some Bazel documentation on how to do memory profiling of rules and what tools you can use to investigate further how to improve especially your custom rules, or maybe public rules that you can contribute to, or even just file a bug that this should be investigated for performance improvement. Actually, maybe I'm going to switch over to this once more. I wanted to also point out that we do have the functionality to view what data was extracted. So when you define datums, you can also provide a summary of the data that's in there. And then you can kind of look at it. And here you can, for example, see that we have a datum for the Bazel phases, which is similar to what Bazel Analyze profile provides. We have some data on the Bazel profile, including the critical path, and then also some other datums that are already implemented, which is a bunch. That can be helpful because sometimes maybe you're just interested in the raw data, and it's especially helpful also for debugging purposes while you're maybe developing a new feature. So this is it. This is how you can extend the Bazel Invocation Analyzer and make it better yourself. The hardest part is coming up with what can actually be extracted and what suggestions are. These, as I mentioned before, this is the expertise that I want everyone to have access to. And with the rationale and the caveats and the texts provided in the recommendations, this can also be a great tool to help others understand better how Bazel works, what is in the Bazel profile, so that they feel more empowered to perhaps investigate themselves and dig deeper into how Bazel works and how they can adjust how they use Bazel to get the best out of it. And then I do hope, though, that once, if you have an idea to extend something, the infrastructure we've set up makes it easy to actually put it into code and share it with everyone. And as I mentioned before, I showed abbreviated code here. There is a lot missing, like edge cases, error handling, testing, whatnot. And you can check out the GitHub repo for the details. And talking about GitHub, if you do decide to extend the tool for yourself, do upstream it, because if you think it's a valuable suggestion for your workflow, I'm sure many others will also find it really, really useful. And we have such a great, thriving community here. We've seen so many people share their hacks, their extensions, and whatnot. And it really helps everyone get the best out of Bazel and have more people using it and just more people being able to develop better and faster and get cool stuff done. So yes, there is some work involved, obviously, but I think it's really worth it. Thankfully, if one person extends a tool, a lot of other people will really profit from it. I mean, that's the idea of open source, right? It's not just you being able to extend it, but everyone being able to contribute and make their lives and their development processes just a bit better. So yes, put in the work once. But the thing is, automation is great. And it's so scalable. Like, why are we as Enschler working on this? We look at Bazel profiles all the time for prospects and customers because we want to help engineers stay in flow, right? That's like in our name, literally. We want people to be able to develop faster because there's so many great ideas out there that we want to put into code to make the world a better place, basically. And if we are waiting and spending time on all of these hurdles and development processes, that's energy and time not spent on solving the real problems we're tackling. And it might be easier to extend the tool than you think because there's a code base there already. We saw in the example, one of the datums we didn't have to implement. Total duration was already there. And as the tool grows, there may be even more like resources that you can leverage to do that. And finally, you are helping others out. We all profit so much from so many open source projects. And contributing yourself can be a reward in itself, because you're giving back and you're helping many others. And that's just, I think, a great motivation in itself too. Talking about contributing, I wanted to clarify that contributing does not just mean upstreaming code. Now, that is a fantastic contribution. But really useful contributions are reporting bugs. If you encounter a bug, report it. Give context. If you can fix it too, that's great. But if we don't know about a bug because we don't observe it in the environment we are in, we don't have the knowledge that this even needs fixing. And requesting features is good too. We will build features that we think are useful. But if we want to help the community, we need to know what everyone else needs. So saying, I have this idea for a suggestion provider, but you don't have the time or resources to implement them is okay. Someone else can take it up. Or like just saying, like, what about this direction? And then seeing how many reactions there are really helps us prioritize on what to work on next. And of course, sharing the tool with others. If you know someone that's thinking about starting to use Bazel or is already using Bazel, point them to the Bazel Invocation Analyzer so that they have another resource to use to improve how Bazel works for them. Really useful too. And finally, just providing feedback. We generate suggestions. Are these helpful? Are these not helpful? So that we know what suggestions should be improved, which ones should maybe be promoted and highlighted more because they're the most useful. So we've tried to make it as easy as possible to provide feedback and to get in touch with us. In the command line interface, we do output the link to GitHub as well as a contact email address. On GitHub, we have a couple of issue templates so that when you do file an issue, it's in a form that we can easily act on it and actually execute. And in the web UI, providing feedback is as easy as clicking one button and just letting us know this suggestion was helpful or perhaps not helpful. All of that's good. And we're extremely grateful to all of the contributions we've already received so far. Go back one. Yeah, that's fine. So we have received a lot of contributions from different people. I had a list in my speaker notes, but I went over it already. So Tobias, Matthias, Christian, Juan, and a bunch more people have provided feedback, and some even added PRs that have been merged, and that's really been wonderful to see. And I checked the usage statistics of the web UI, and I have seen some of you have already tried it out, so that's fantastic to see. I wanted to go back to this slide actually, where I talked about external inputs, and so far we're doing just the Bazel profile. But the architecture is set up in such a way that there can be other inputs. So, for example, when you run remote execution, the remote execution might also generate a profile for all of the remotely executed tasks. That makes a lot of sense. We do that when our customers run their builds against our remote execution service. We generate an Enchlow profile, and indeed we've already extended the tool so that you can analyze the invocation, which takes both the Bazel profile and the Enchlow profile and looks at both of those data sets. But there is a lot more data that is valuable because the analysis of the Enchlow profile is not in the open source repo, simply because only people using the service actually have access to that Enchlow profile, so it doesn't make a lot of sense to open source it. However, there is a lot of inputs that every Bazel user has that can be analyzed and could be hugely helpful in providing more, better, different suggestions. What about the BEP stream? What about the action graph? What about all of the inputs from A query, from C query, whatnot? What about the source code, indeed? Or right now, we have an expert system, right? Someone says, this is a pattern, this is the data we extract, these are the suggestions we make, and there you go. What is the potential of applying machine learning to this? Or taking it in a different direction, what if we analyze the profiles or the data of multiple invocations? If you look at all of the invocations, is there a pattern? Will that maybe surface which things to target to get the biggest wins most quickly? Or if you look at profiles from the same invocation over time, what does that surface? And taking it a step further even, what if it was interactive when the tool doesn't just take some static inputs, but it actually has the power to run Bazel with some modifications, fetches all of the data at once, then maybe makes some adjustments, see whether that improves in performance, and then puts together like a change that you can review and you can think about applying. Like, that would be cool, right? How can we, like, for example, we've seen a bunch of presentations talk about like automatically generating build files or automatically removing dependencies from build files that don't need to be there, which can have an impact. So that really, really excites me, like streamlining this process. And there's so much more we can do. So I started with like saying like there is so much potential in these Bazel profiles, but it's hard to read them right now. And you know, now we're the first step in the right direction of making it more accessible and making it easier to use, that you use it more often, you use it regularly, and we improve upon it to make it even more automated, so that everyone can really leverage that power that is in the Bazel profiles without knowing a Laszlo who shows them the ropes, without having to attend a workshop, by just, you know, empowering everyone to have access to that. So I hope you see that potential too. And I hope you head over to analyzer.enchlow.com to analyze your profiles and just see what it tells you. Provide feedback to us so that we know what to work on next, and get in touch with us if you want to contribute. We're so welcoming all of that. And of course, you can also download the source code, look at it, or run the command line tool. All of that is fantastic. So finally, I just want to point you to the GitHub repo, the web UI, and also the email address. You can also catch me here and talk to me. I think we've also got some business cards lying around that have all of these links on there, so that you can take them along for yourself or someone else you know. And for everyone joining virtually, you know, there's a lot of ways to get in touch async. I mean, most of the time, we're not in one place in any case. So we're used to making cool stuff happen while we're all in wherever we're based in. So yeah, I'm excited for this, and I hope you all agree that when we all pull together, we can make Bazel even more awesome for everyone. Thank you.